This problem involves partial pressures. A 50.0 liter balloon contains 0.500 moles of oxygen gas, 0.500 grams of hydrogen gas, and an unknown amount of helium gas. This balloon is heated to 35.0 degrees Celsius, and the total pressure was found to be 0.615 atmosphere. We want to calculate the partial pressure of each gas inside this balloon. We will begin this problem by calculating the partial pressures of the oxygen and hydrogen gases using the ideal gas law, PV equals nRT. Let's start by calculating the partial pressure of oxygen. Rearranging PV equals nRT, we find that the partial pressure of oxygen gas is equal to the number of moles of oxygen gas times the ideal gas constant times the temperature in Kelvin divided by the volume in liters. Plugging in our numerical values, we find that the partial pressure of oxygen gas is equal to 0.253 atmospheres. Now we need to calculate the partial pressure of hydrogen gas. Before we can do that, we need to convert the mass of hydrogen to moles of hydrogen. We know that the molar mass of hydrogen is 2.02 grams, so we can convert 0.500 grams of H2 into moles of H2. Again, we will use the ideal gas law, PV equals nRT, to calculate the partial pressure of hydrogen. Rearranging PV equals nRT, we find that the partial pressure of hydrogen is equal to the number of moles of hydrogen times the ideal gas constant times the temperature in Kelvin, all divided by the volume in liters. Plugging in our numerical values, we find that the partial pressure of the hydrogen gas is 0.125 atmosphere. Now we need to calculate the partial pressure of the helium gas. To do this, we will simply take the total pressure minus the partial pressures of the oxygen and the hydrogen. We were told that the total pressure inside the balloon was 0.615 atmosphere. We calculated the partial pressure of oxygen to be 0.253 atmosphere, and we calculated the partial pressure of hydrogen to be 0.125 atmosphere. This gives the partial pressure of helium a value of 0.237 atmosphere.